So for the first part of our prototype, we're going to demonstrate how we're going to actually break down the dry ice into a form that's going to be food safe and people safe. This dry ice we got today from Purity. And I'm just putting this into our machine. And this machine actually will just break it down, as you can see here. Great. So this machine breaks down our dry ice into a very fine powder. This is almost microscopic. Once it's being added to food, it's not going to clump up. It doesn't clump up in here at all. So this is the way that we're going to actually break down dry ice. And now we'll actually show you how we're going to make our ice cream mixture, just using a mixture of heavy cream and this dry ice and mixing it right now. So Alan, do you want to grab this cup? So just use this cup.
Go for it.
Sure. So kind of limited on space here, but we're going to use 1/3 of a cup of this solution, which is just heavy cream. It's almost the same thing that we'll be using here, so really not that much. And then we'll take about a tablespoon of the dry ice mixture from this. We'll demonstrate how the dry ice is actually going to fall into the cup afterwards. So we drop the dry ice in here. We'll use our whisk and then begin whisking. So while this doesn't get very, very hard immediately, it does start to thicken, and we get almost this milk-shaped type consistency after just a few minutes of whisking. So after continuous whisking, it starts to get harder and harder, and then we finally get to an almost ice cream product. Before we serve this, we're going to have to let it sit just to allow some of the carbon dioxide to just air off. But then after that, we get a product that doesn't fall out. All right.
So it's worth adding that continuous whisking can help drive the carbonation out of the solution.
Sure.
And that. Recording.
All right.
So we're going to demonstrate our distribution mechanism for our dry ice in our dry ice ice cream maker. This is the pulverized dry ice that we made earlier. Notice that even after a few minutes, it is still not clumped up at all. It's still a very fine powder. It does not cohese. What we're going to do is going to put this gravity bin style contraption on top of a puck with a hollow cutout right here. And if this hollow part is above a surface, there will not be any sort of ice falling out. And here is where ice will actually enter the cutout right here. And if we turn it, it will empty out into our cup. So let's demonstrate the mechanism in action. So here's our cup we're going to use. So we're going to put our gravity bin on top of it. Okay. Now this is, although it's not completely pressure sealed, which is good. We don't want this exploding on us. But we're going to turn it a couple times just to show that ice will indeed fall into this hole here. This is our footage of the distribution mechanism that regulates both dosage and flow of the dry ice. So this puck is first going to turn to take on a load of dry ice. As you can see, the cutout is filling. Needs to be more on the table. The cutout is filling, and as we turn further, we can see that the cutout is full, and as it turns off of the solid, no dry ice is coming out from our gravity bin, and all of our dose is in the cup. Yeah, and that's our demo. Hi, I want to demonstrate our proposed fluid distribution system. This is designed for our ice cream mix into the cups, but could potentially even be extended into something like a loose chocolate syrup. So basically, in this contraption, we have a very tiny straw. This was all that we had around, but the real straw would be adjusted to accommodate the thickness of the mixture. It's sealed as best we can do it right now without rubber washers, O-rings in this cap. And we have a small hole that we drilled into this water bottle right where my index finger is. And if I turn this upside down while our sealing lasts, this is not going to, the liquid is not going to come out of the straw unless I release my finger. Now, in place of my finger in the actual product, we would actually have a valve which would control airflow, which is quite practical. Another advantage of this design is that it doesn't require much cleaning, and we can very easily change batches of solution by just taking our designed cap off of our solution bottle and then replacing the solution bottle or refilling it. So it's very modular. Okay, let's give it a demo. Turn it upside down. No water comes out, or very little. That's just error in our
it's just because it's a basic
pressure in our pressure containment. If I release my finger, water starts to come out.